today we are going to learn about the scientific method, which is chapter 1.2 in your textbook.
Have you noticed that Howard can take any topic and use it to remind you that he went to space?
Interesting hypothesis. Let's apply the scientific method. Perform an experiment.
Okay. Hey, Howard, any thoughts on where we should get dinner?
Anywhere but the space station.
I mean, on a good day, dinner was a bag full of meatloaf. But hey, you don't go there for the food, you go there for the view. It's fascinating. Let me see if I can duplicate the result. Howard, I've always thought the lemon was an underrated fruit. Care to weigh in?
Not really.
Oh, well.
You know, people say the Soyuz capsule is a lemon, but...
Yeah, but hey, that baby got me to space and back.
All right, thinking about what you know about the scientific method from past science classes, what steps or what parts of the scientific method did you see in this video clip from the Big Bang Theory? So today, when we take notes, you're going to take notes on the next available blank page in your notebook. And we are going to be using Cornell notes in this class. So the first thing you need to do is up on the top of the page, you're going to put Scientific Method, Chapter 1.2. This is the title of the page. Be sure that you also put this in your table of contents. Next, you want to make sure that you have the page number in the upper outer corner of your page. And you're going to sign and date the bottom left corner of your page. Now for Cornell notes, what we need to do is we're going to make a margin that's a little bit wider or bigger than the built-in margin on the page. So go ahead and draw a straight line. You could use your ruler from your planner. You can use another book. Use something to be able to ensure that you get a straight line that's about an inch away from the current margin of your page. Now when we take notes today, you're going to take notes to the right of this new margin that you just drew. So go ahead and get your page ready, and then you're going to begin taking notes. So first, how science works. The first thing scientists need to do, the first thing you are going to do when we're doing labs and activities in this class, is you're going to ask a question. And usually it's based on observations that you might make, or it might be based on what we're learning on in class, what you read in the textbook, things like that. Next, you're going to form a hypothesis. And remember that a hypothesis always needs to be written in the if, and, then statement. You can refer to your hypothesis worksheet on how to write a hypothesis. Next, you're going to set up a controlled experiment. So if you were testing if plants grow in different color lights, you want to have plants that maybe grow in red light, green light, and blue light, but also have plants that just grow in regular sunlight to compare or see the difference between those different colors. So that's what a controlled experiment is. You only want to change one variable at a time. So if we were watching this plant, you would want to just change the color. You wouldn't want to change the amount of water that you're planting the plants or the amount of fertilizer you're getting. All of that needs to stay constant, and you're only going to switch to the one variable that you are testing. You also need to be able to identify those independent and dependent variables. Those are really important because, again, that's part of what goes in your hypothesis, that's what goes in your data table. But the variables are what you're going to be looking for when you're setting up this controlled experiment. You also are going to need to record and then analyze those results. What do those results mean? At this point, maybe you have some more questions and you repeat the process. Or you need to come up with your conclusion. And again, with that conclusion, maybe it brought up some more questions and you're going to do another experiment to test out what you have concluded. Now, informally, this could be called the scientific method, but it's not necessarily linear. You're going to have questions throughout the whole thing. Maybe your hypothesis might change. You're going to record results and analyze them and come up with more questions. So the process of science is actually very fluid. It doesn't necessarily go in this exact linear fashion every single time. One of the big things that's really important when you're doing an experiment is that it should be able to be repeated. You want other students in the class to be able to repeat your exact procedures. So your procedures need to be explicit and so anyone knows exactly what it is you did. Nature behaves in a consistent manner. So if something happened, it should be able to be tested or experimented on again, unless there was some sort of fluke, which could happen as well. So your results need to be repeatable for it to be accepted by the scientific community. Now, a lot of times I hear people say, well, it's just a theory. Okay, in science, a theory is actually really important. It's a well-tested explanation, and it unifies a broad range of observations. People will say, well, oh, I have a theory that so-and-so does blah, blah, blah. Okay, that's just kind of a hunch. But in science, a theory has been tested over and over and over again. It's been experimented, it's been repeated, and it's come to this idea that it's well tested and everyone agrees. Another thing you might have heard of are scientific laws. And scientific laws are descriptions of an observed phenomenon. For example, in physics, you might have heard of Newton's law of motion. A law doesn't explain why the phenomenon exists or what causes it. It's just a description. The theory is what explains what causes that law to occur. So now you should have notes in the notes section of your page. After you've completed taking your notes, you need to do something in the left-hand margin. That's why we made it a little bigger. I want you to come up with 5 questions that you're going to write on the left-hand margin. And these are questions that can be answered by what is in your notes. So for example, where you just wrote about the difference between a theory and a law, you can have a question on the left-hand side that says, what is the difference between a theory and a law? And that'll be right to the left of where you wrote those definitions. And this will help you when you're studying for your exam. You will be able to fold the paper over, read the questions, or have someone quiz you, and the answers will be on the right-hand side of your page. I want you to have a total of 5 questions for this set of notes in your left-hand margin. After you've written your questions, you can go ahead and pause this right now to write your questions. But after you've written the questions, what you're going to do is you're going to draw another line on the bottom of your page at the end of your notes. This could be on a second page if you ran out of room. What you're going to do under this line is you're going to write your summary. And your summary is a summary of what the notes were about. I don't want you to just copy things down that you wrote in your notes. I want you to put it in your own words. But today, it's not going to be a written summary. Today, what I want you to do for your summary is you're going to do a visual summary. I want you to sketch out the 5 steps of the scientific method from your notes, and you're going to have one small picture for each step. And that will be your summary today. So you don't need to have a paragraph. You're just going to sketch out the 5 steps down at the bottom of your page in the summary section.